So now let's have a look to the different modes that we can have, and we will take as example the valve AC because it is the simplest valve and good for demonstrations. So right now I am showing you on the left of my screen the Rockwell PLC code that is running and online with a PLC, and on the right a partial view of my in-touch applications with the valves. Like this, I will be able to demonstrate to you the different states. When the operator displays a faceplate, he has the access to the different buttons. For the simulation perspective, I have added this faceplate object on my screen directly. So, as an operator, I can see that my valve is on auto mode. So I can read first the status. Then I have two commands button for the operator to set the actuator in manual or in auto. So now, if I click manual, I can see that my icon here has changed and get this M on the top right of the icon. If I switch back to auto, the M disappears. Now from the PLC side, I can see that here I am on automatic because I have this automan bit which is set to 1. Now if I switch back to manual, this bit is resetted. You have two commands for the operator, operator request and operman request, which are linked to the SCADA system. And you have as well two internal bits, progauto request, progman request, to lock the automan in a specific mode. So now look at the operator commands to open and close a valve. So on the PLC code, I will display the rung for that. And I still have my in-touch faceplate for the valve AC. So right now, my valve is on manual mode. If the operator click on open, the valve open, and the status is updated on the faceplate as open. And if you click on close, the valve close. You can see here the icon that change colors from white to gray for open and gray to white for close. Now, on the PLC code, here, we can see that we have the open request command right here. So if I toggle this bit, I switch on my command status. If I toggle the operator close request, I release the command status. This is for the manual options. In automatic, okay, so I switch my valve to automatic. I will use my proc command. Control T, toggle. Now my valve is open. Toggle back. Now my valve is closed. For process and secure interlocks, there is another video to provide the definitions and demonstrate how to configure them. As we just had a look to the proc command, let's continue and have a look to the out reverse options. So for that, I will go down into the PLC code to the rung 6. Here it is. So in the rung 6, we have this out reverse bit and the output. The output bit will be aliased to the physical output channel to open or close your valve. So if we have a deeper look, so basically when you have a command status and the out reverse at 0, basically we are going to recopy on the output the command status. If the out reverse is set to 1, then the output will be the reverse of the command status. So it will be set when the command status is 0. One important reminder is to always program the proc command for the conditions to open the valve. Then you use the out reverse options to reverse the output. Regarding the open and close states. So let's have a look to the PLC code first. So as rung number 4, I have my open state, which is conditioned by my simulation mode. So basically this open state information can be simulated. And for that, we have two information simulated, the feedback close and feedback open. In case the simulation mode is 0, then we will look at the physical information from the input channel of the feedback. So here for the feedback close, we have two options. Either the feedback close is disabled and then be passed, or the feedback closed is enabled, and then we will look at the input channel informations. Then we continue. For the open state, then we will look at the command status to be set, and we will make sure that we have the feedback open in case it is not disabled. Otherwise, we will bypass this information and then we set the open state. For the rung below, the rung number 5, we have a similar logic for the closed state. Instead of looking at the command status to be set, we look at the command status to be 0, and the feedback close to be set, the feedback open to be 0. So now you can see a simulation mode. When I switch to open, my closed state will be 0 here. When I switch to close, my closed state is 1, and the same for the open state. If I open my open state, switch back to open, when I close, my open state switch off. As I showed you, in the open state and closed state, we can simulate the feedback open and feedback close. So for that, I have slightly modified my HMI with the simulated close feedback and simulated open feedback. And now I'm going to show you where it is on the PLC side. So it is at the very bottom of the routine. So the two last rung. So 16 and 17. So on rung 16, here is the simulation open feedback. So basically on simulation, you have two options. Either you simulate within the add-on instructions the feedback open based on the command status, as I am highlighting here. Otherwise, you can simulate the feedback open signal from an external system. So first, I will change the preset to 2 seconds and a half. And now if I close my valve, next opening, my timer will have to reach the 2500 to set my feedback open. So I click on open, I'm counting, and then my sim feedback open is set to 1. Close, open, etc. So the other way to simulate is to use an external system, an operator training system. So you can set this bit sim feedback open signal to 1, and now, so you can do it from the PLC or from the SCADA. And now I will toggle this simulate digital input. Okay, so now when I will go to close, my simulation system need to release my simulated output feedback and set my close feedback, and vice versa. If I open, I uncheck my close feedback and I check my open feedback, right? If you remove both, then a fault will be displayed. That's it for the simulation of the valve AC. As we are now able to simulate the close feedback and open feedback, I want to show you the 4 different faults. So let's go into the code. So here, rank 7, we have the actuator stall. So the actuator stall is set when you send a command and the valve does not move from the original feedback. So right now I am in open status. So right now I am in open status. I have the simulated open feedback set. I will request the close and I will not change the open feedback. So click on close. I'm in transition. And then I have the error actuator stall. Now I will go back to open. The fault will be resetted. So this is true when I want to go to the close position, but as well when I want to go to the open position. So right now I will go on the close position without error. So now my simulated close feedback is set. I will click on open. I am in transition. You will see the fault that will come, actuator stall. So to reset the fault, I go to the open. I switch on the open feedback, and then I have my open state. So this is the actuator stall. On the actuator stall, you can preset the timers. By default, they are all at 5 seconds, but you can change them. So the open transit fault, so let's close the valve without error. I will click on open. I will release the feedback, but no open feedback. So click on open, release the feedback. So I am in transition. And then I am failed to open. Once I select my open feedback, the fault is released, and I am now in open state. If I continue into the code, I have the close transit fault. So if I click close, I release my simulated open feedback. I am in transition, and now I am failed to close. I switch on my simulated close feedback to release the error. And then the last one is for the sensor feedback error. I can switch both to 1, which is physically not possible. And now I have the fault, feedback fault. So as I'm supposed to be close, I remove my open feedback to release the error. So if we look into the code in rug 11, here I have the 4 faults that will set the fault alarm. This fault alarm will set my alarm memory. That will be the information in my alarm banner for the operator, and this bit will be maintained until the operator acknowledges the informations. We have as well a counter of the alarm memories for the whole PLC. So right now, if I toggle this alarm acknowledge bit, my alarm memory is now released. That's it for the fault and alarm memory. To finish, the last information to demonstrate is the mode alarm. So let's navigate into the code to the mode alarm. That is here. The mode alarm can be set only on manual mode. So to latch it, I need to raise an automatic command to open the valve. So I switch on my proc command, and you see that the mode alarm has been latched. I have the mode alarm display on my faceplate, and I have an orange square behind the valve. I can release the proc command, and the mode alarm will disappear. Otherwise, it will be disappeared when I switch back to automatic mode and I release the proc command. So let's switch to automatic mode. And now, if I release my proc command, the mode alarm disappears. That's it for the whole Valve AC. I hope you enjoyed the e-learning. Thank you. Bye-bye.